Hi everyone, this is Jay, your instructor for computer networks, and the topic that we are going to see is routing in the network. So let's start. So the first question that I will ask you is that what is routing and why it is needed? By definition, a routing is a process of selecting path along which the data can be transferred from source to destination. Suppose you want to send message to your friend who is sitting far away from you. Now there are many devices and many networks are present between you and your friend. So it is a responsibility of the network layer to forward the message using the best path so that the data can be reached to destination. And there are in fact special devices are there to perform this job, which are called as router. So all the routers is having routing table, and whenever router receives any packet, it analyzes the packet, and after analyzing it checks its routing table. After that, the router will select the best path among all the available paths so that the data can be reached from source to destination as quick as possible. There are three types of routing. The first one is called static routing, dynamic routing, and the default routing. Now what is static routing? In the static routing, the entries in the routing table can be only changed manually. So whenever there is any change in the network administrator will change the entries in the routing table by his own. In the dynamic routing, all the routers are smart and all the routers are sharing information with each other. So in the dynamic routing, the entries in the routing table are changed by the routers itself. And the last one is called default routing, and in the default routing the entries in the table cannot be changed. Now let's see the types of routing protocols. Each and every router are working on some routing protocols. There are mainly two types of routing protocols: the static routing protocol and the dynamic routing protocol. The dynamic routing protocol is divided into two types: interior gateway protocol and exterior gateway protocol. Now, where the interior gateway protocol is used, interior gateway protocol are used within an autonomous system. What is autonomous system? Autonomous system, it is a network in comparatively small geographical area. For example, it can be networked at your office or it can be networked at your college or in your lab. So at there, interior gateway protocols are used. Exterior gateway protocols are used between different autonomous systems. The interior gateway protocols are having two types, which is distance vector routing protocol, and the second one is called link state routing protocol. The exterior gateway protocol is having only one type, which is called path vector routing protocol. Now we are going to see the distance vector routing protocol. So let's see. In the distance vector routing protocol, each node shares its routing table with its immediate neighbors periodically or when there is a change. For example, all the routers can be sharing their tables by every 5 seconds. And if there is change before 5 seconds, they can share their table. You can see there is a network which is present on your screen, and there are total 4 routers which are A, B, C and D, and they are connected via a link, and distance can be seen near those links. Now in the initial phase, all these routers are having table and those tables are empty. Now what is the meaning of this table? For example, router A's table indicates the distance from A to all the remaining routers. The entries in router C's table indicates the distance to all the devices, all the routers from the router C. So initially there are no entries are there on the table. Now in the starting phase, router only knows the distance to its adjacent node only. For example, for the router A, the distance from itself is 0. Now the distance from A to B is 4 and distance from A to C is 2. But the router D is not connected to router A directly, so router A doesn't know the distance from itself to D. So in that case, it will put infinite in that field. Now what is the meaning of infinite? Infinite means that right now the router doesn't know that how to reach to the destination. So router A doesn't know that how to reach router D. So right now it is putting infinite in that field. So let's see C's table. Now C knows the value, C knows the distance to A, which is 2. C knows the distance to B, which is 1, and C knows distance to itself. But C doesn't know the distance to D because router D is not directly connected to C. So C will put infinite to its entry. So after initial phase, all the routers will share their tables to adjacent routers. Right now we are interested for device A only. So router A will receive table from its adjacent routers, which are B and C. So A is received the table from C. After receiving the table from C, A will add 2 to all the entries in receive C's table. Now why it is adding 2 to every entry? So what is the meaning of C's table? The value of C's table tells you the distance to all the routers from C. So A knows that if A wants to reach all the routers via the C, then it has to add 2 to C's table. So it is adding 2. After adding, A is having 2 tables, the new table and old table. And A will compare all the entries in 2 tables. And after comparing, it will keep the list value and it will update to its own table. So for example, it will compare the first entry and what is the minimum value among these two values, which is 0. So it will not make any change to its own table. In the second entry, it knows the minimum value is 3. So router A will update its table with 3. In the third entry, there is no change that needs to be done, and which is true for the last entry too. So right now, the still device A doesn't know how to reach to device D, but device A has find the minimum path to reach the device B. So from this entry, device A, if device A reach to device B via C, then it can reach at minimum cost. Okay, and what was the previous cost? The previous cost was 4. So after sharing, it has updated its table. Now A will receive the table from device B2. So it will receive table from device B, and after receiving B's table, A will add 4 to each and every entry of device B's table. What is the reason behind that? B's table tells you the distance to all the devices from B. So device A knows that if A wants to reach all the devices via B, in that case it has to add 4 to all the entries in device B because the distance from A to B is 4. So A will add 4 to each and every entry in the receives B table, and again there will be two tables. Now A will compare two tables, new table and old table. So let's compare the first entry. So what is the minimum value in the first entry, which is 0? So A will not make any change to its own table. What is the minimum value in the second entry, which is 3, which is already minimum value, so A will not make any change in its own table. That is true for the third entry too. But in the last entry, the A's table has infinite value, but the new table is having 7 value, so A will change 7. So A has find new way to reach the D, which is via B. So if A want to reach to D, it can reach via B, and the cost to reach D is 7. So this is how all the routers will receive the tables, and they will make some calculation, and after that entries in each router's table will indicate the minimum distance from itself to all the routers. Okay, so we have calculated the minimum distance from device A only. Now for the remaining routers you need to find by yourself. So this is how the distance vector routing algorithm works. If you have any doubt, you can ask me into the comment section, and meet you guys to the next video lecture. Thank you so much.